You decent athletic. You wrote it on my paper. I wasn't here.
I sometimes make mistakes on that, so hold on. Let me double check. Vertex form. Solving quadratics by factoring is page 57. So, solving quadratics by factoring. Guys, if you have a question on the EOC that says, I need you to solve the following, even if it's not a quadratic, if it's just a regular equation, do you know the hack on Desmos to solving?
Yes.
Make a table.
I didn't even have to make a table.
How to make a table?
You type it in Desmos and you look at where it's.
Wait.
Where are the solutions on a graph? Where it's crossing the x-axis, the x-intercepts. So even though it says solve by factoring, you could just go to Desmos, type it in, and see where it's crossing the x-axis. Okay? Now, you still need to know how to factor. And I imagine you didn't practice factoring over the break. But if you recall, actually, I got ahead of myself. The x-intercepts are the solutions to a graph. Harley, I need you over there looking at the board. You can't.
I can't do anything on my Chromebook.
You don't need your Chromebook right now. You need to be on this notebook paper. This paper.
I don't have that.
At the bottom of the paper, on the Thursday before the break, we talked about how there's different scenarios for solutions. What are they? What are the possible scenarios for the solutions to a quadratic? What are the possible scenarios? How many possible solutions could you have? You could have two. Nope, you cannot have three. You know why? What's the degree of a quadratic?
I think it's really bad.
So what is the degree of a quadratic?
2.
It's a degree 2. You cannot have 3 solutions for a degree 2 polynomial.
It's really bad.
The degree of the polynomial sets the bar for how many possible solutions. So if you have a degree 4 polynomial, how many possible solutions could you have? 4. What is the degree of a quadratic, Ty?
4.
No, and we just talked about it.
2.
Yeah, thank you, Kason. It's degree 2, yes. You can have 2 solutions, 1 solution, or no solution. How is it possible to have no solution? Where would the graph be?
Above the x-axis.
Or
Below it.
an opening in which directions?
Up. And down.
Opposite of the x-axis, right? It could be above it, opening up, or it could be below it, opening down. If you have a solution, the graph will cross the x-axis. Let's say it all together. Solutions to a graph, or let me change it. Solutions to an equation, say it.
Solutions to an equation.
Not everybody said it.
Solutions
to an equation. Not everybody said it. Solutions to an equation are where it crosses the x-axis.
The x-axis.
Okay? Now, zero product property. We said if you've got this simple equation and you're trying to solve, what do you know about either x or y? The only way to multiply 2 things together and get 0 is if one of those 2 things was 0. That's one of the one of the beautiful things about math is if I know I am multiplying and I am getting 0, then I know for a fact 1 or both, right? Could be both. Both or 1 could has to be a 0. So we said, let's make it ugly. This crap times this crap equals 0. So what does that mean? 1 or the other or both has to equal 0, right? So either this crap equals 0 or the other must equal 0. Which brings us to the zero product property. When it's in factored form, this is factored form, a binomial times a binomial equaling 0. Because I have this times this and I know it equals 0, this lets me know that one or both of those factors must be 0. Do we have a way of knowing which one it is? No. So we assume they both equal 0. So we pull them out and we set them equal to 0. We pull this and this and we say, well, x plus 4 must be 0 or x plus 5 must be 0. And then we solve them each. So here subtract 4 and here subtract 5. This is a set notation. Notice the squigglies. This is not parentheses. This is a set, meaning the set of solutions. Or you can call it solution set. There's multiple ways to write it. But the solution set here would be -4 and -5. What would it look like as x-intercepts? It would be -4, 0 and -5, 0. Those would be the x-intercepts. So looking at the next one, x minus 3 times x plus 7 equals 0. If I was going to solve this, I could use the zero product property, or I could go to Desmos and type it in. X minus 3, x plus 7, equals 0. Look at that. Where's it crossing the x-axis? Right here at -7 and right here at 3. Those are the solutions. What are the factors? The factors are x minus 3, x plus 7. I need you to know the vocab. These are called factors. We pull them out and we set it equal to 0. So this is 3 and this is -7. And then these are called roots, solutions, x-intercepts, or zeros. You should be writing. I'm writing. You should be writing. Everybody should be writing. You don't have a pencil, do you? I can give you one if you need it. You have a pencil? Now, these are a little bit more complicated because now what we have to do is solve a two-step equation. But it doesn't change the fact that you set them equal to 0 and you solve. That's it.
Does it matter which one you put first?
No, because it's just a solution set. Ideally, you would probably list the smaller one first. I don't know what the state's going to ask. I don't know if I doubt the state would do it like this. I think they're going to either have it as points. So this is points. or they may just have it like that where it's just the number. I'm blind here on what the state's going to ask. So what you get is the solution from this one. You're going to get a fraction, and that's okay. Fractions are not bad. Back to 5, and then divide by the 2. If they want fraction form, you leave it as a fraction. If they want a decimal form, you can go to the calculator and divide it. You will have both calculators, the handheld and Desmos, for the EOC. You can use whichever one you want the whole time. I would strongly encourage you to use Desmos for graphing. We've talked about how it's way easier, okay? We also talked about how to make the table in Desmos, how to use the graph where it crosses the x-axis to solve it. Now, we're putting what you just did in an equation where you have to actually factor it. So if you come back up here, these were already in factored form, right? So this was like the last step of solving by factoring. Notice down here, this is not in factored form. You have to get it in factored form, then you repeat the steps at the top. So the first thing you need to do is get the equation in standard form. Notice standard form means that everything is on one side of the equal sign and then it's equal to 0. That's standard form. Then you're going to factor the quadratic equation. Now remember, you could factor just GCF, or it could be the box method, or it could be both. You could have a GCF that needs to come out, and then it could do box method. Okay? Then you're going to use the zero product property to solve. This means you set each factor equal to 0 and solve. So solving this by factoring. First of all, let's say you don't know how to do it, right? Well, I feel like everybody should be able to get in standard form. So what would I move first to get this in standard form? What needs to go?
The exponent.
No, I'm getting it in standard form, right?
You have to get the
I need everything to the left. Think of Beyonce's song to the left. Or you can think of Cha-Cha Slide. I like Cha-Cha Slide better than Beyonce.
Yeah.
But to the left. Everything to the left. So what needs to move, y'all?
To the left.
It's positive, so I'll move it by
Subtraction.
It's a cup game. It's going to shuffle over here, and it's going to change to negative. So x squared minus 5x equals 0. Then you're going to go to Desmos, and you're going to type it in. X squared minus 5x. And then you're going to look at where it's crossing the x-axis, because those are your what? Those are your solutions. It's crossing at 0 and at 5. Winner, winner, chicken dinner. Problem solved. But what if the state says, which of the following would be the next step in solving this by factoring? Because I've seen that in some of the practice problems. That means they don't really want you to solve it. They want to know, do you know the process? So this would be step 1, and then step 2 would be factoring it. Always check for a GCF. is there a common number GCF, numerical GCF, or variable GCF?
Variable. X.
Yes. Don't forget to wait a few seconds, but you're right. Do you notice the numbers are 1 and 5? Is there a GCF between 1 and 5 that's helpful? No, just 1, but that doesn't help, right? But they each have an X, and you can only pull the smallest exponent. So I can pull an X out. I'm going to leave some space because I know some of you like this technique when you're dividing. I'm going to divide by my GCF, and I'm going to write what I get. What do I end up with? This X cancels the 1 on top, and this cancels this one exactly. And you're left with X minus 5. Now you have, in factored form, something times something equals 0. Enter zero product property. So this right here is going to equal 0. Not much to that. And then X minus 5 is going to equal 0. Well, what's the solution there? Well, this just confirmed what we found by typing it in Desmos. We came to 0 and 5 as our two solutions.
What happens if there's no variable that's if there's no common variable or anything?
If there is no GCF at all, you would go to box method. Hey, I couldn't figure out how to. Okay, well, I'm going to let you struggle with it, and then once you nail it, show me how to do it, because I could not figure it out. All right, now, this was just a GCF. Make a note here. This was GCF only. Now what we need to refresh you on is when it is a box method. And did I give you the second piece of paper that goes with that?
No.
No? Okay, let's do this. So look at number 5. Is there a GCF here? Is there something all three terms have in common? No.
Nope.
Not other than the number 1. Is it in standard form? Yes. Is it equal to 0? That's all you got to ask.
Yes.
Yes. We're going to do the X game, and then we're going to do the box method. So here we go, refresher, because you're going to have a very short Delta Math assignment refreshing you on this. So we've got 1 times 12. 1 times 12 is 12, and B is -7. So let's think of the factors of 12 that add to -7.
-3, -4.
-3, -4? Yep. All right, box method. Here we go. Draw your box big enough so it's not crowded. Refresher on what goes where. First term, first box. Last term, last box. The 2 you came up with here go in the diagonal, and you need to put an X with them, okay? This should start coming back to you.
I remember.
Now we have GCF. Pull GCF to the left, check at the top. Here we go. What's the GCF between these two? X. Let's write what's left. X, -4, and then the GCF here, y'all. -3. Very good. Y'all can go ahead and pack up. I'm going to finish the problem though.